there. Before we begin, I have a question for you. What does a balloon animal have to do with equilibrium? Pressure. For today's discussion, we will be covering how to express equilibrium constants in terms of pressure, and predicting the direction a reaction will proceed in. For gas-phase reactions, the equilibrium constant can be expressed in respect to the pressures or partial pressures. This is because gas pressures is directly proportional to the concentration. If we recall from the ideal gas law, we can rearrange this so pressure is equal to concentration times the gas constant in temperature. When writing the equilibrium constant and reaction quotient, we use subscript P to show that these values were derived using partial pressures instead of concentrations. So this means Kp and Kc are not equal. In order to convert between the two, we will use the previous equation relating pressure and concentration together to derive the relationship between Kp and Kc. This expression simplifies to Kp is equal to Kc times the parentheses of R times T raised to the change in moles. The change in moles is equal to the sum of the product coefficients minus the sum of reactant coefficients. Remember from the previous lesson that it is important to take into account the states of your products and reactants, and if you have a pure liquid or solid, they do not appear in the equilibrium constant equation. Now here's a small question. When does Kc equal Kp? This occurs when you have equal number of moles on both the product and reactant side. By comparing the reaction quotient to the equilibrium constant, you can determine the direction in which the reaction is proceeding in. If we take, for example, the general formula for Q, which is equal to the product concentration over the reaction concentration, if you increase the amount of product concentration, Q will become larger and vice versa. If you increase reactant concentration, then Q becomes smaller. If Q is less than K, then the reaction is not at equilibrium, and the reaction will progress to the right or until Q equals K. In order to shift the reaction towards the products, reactant concentration must decrease while product concentration increases until equilibrium is reached. However, if Q is greater than K, then the reaction will favor the reactants until Q is equal to K. In order to do so, the product concentration must decrease, and the reactant concentration will increase until equilibrium is reached. As a brief recap, the reaction quotient is used to determine whether a system has reached equilibrium. If it hasn't, it can be used to predict the direction of the reaction by comparing the magnitude of Q and K. Keep in mind that changes in any way to the system will shift it towards a specific direction. If Q is less than K, then the reaction will go to the right, forming more products and decreasing the concentration of your reactants. Whereas if Q is greater than K, then the reaction will proceed to the left, which means reactants are forming and the product concentration is decreasing. When Q is equal to K, this means the system is at equilibrium and no further changes will occur unless conditions are changed. Thank you for listening and have a wonderful day.